So in this video, we are going to discuss about a problem on step response of RLC circuit. So this is the circuit which is shown in the figure. They are asked to find out I of t and IR of t. Okay, for t is greater than 0. So this is how the circuit look like. Okay, so when t is equal to 0, that is t is equal to 0 or greater than 0, the switch get closed. Okay, and you can see I have a resistor, inductor and capacitor. Okay, so 30 into u of t is nothing but a step response. Okay, so when t is greater than equal to 0, u of t is 1. Okay, so this is a condition. So when this is u of minus t, okay, it is not u of t, 30 into u of minus t. It is not visible properly. Okay. I want to change that one, u of minus t. And so what is the initial condition for t less than 0? For t less than 0, I need to find the value of the current passing through the inductor and voltage across the capacitor. Okay, so for that one, I have to, if I have a capacitor, I have to open circuit, and if I have an inductor, it has to be short circuit. So at t is equal to 0, the circuit will look like this, because the 4 amps current is not connected to the 20 ohm resistor, right? So this is how it is. Okay, so when u of minus t means from 0 to less than 0, it will be 1. Okay, that is t less than 0, it will be 1. So this is how the circuit is. Okay, so what I should do if I have capacitor means I should open circuit. So if I open circuit, I have these two resistors, that is 20 and 20 ohm resistors in series, right? If it is in series means I can add that value. So okay, so if I add the value, I will get 40. So what is I is equal to, otherwise I can apply voltage divider rule, right? So if I apply voltage divider rule, I can find out the voltage across a capacitor, where now the capacitor is open circuit, so the voltage is across this 20 ohm resistor. So Vc of 0 minus is equal to 30, that is the total voltage, into 20 divided by total resistance is 40. So answer is 15 ohm. Okay, 60 divided by 40, 3 divided by 2, so 600 divided by 40. Okay, so you will get 15 as answer. 15 volt is the answer. So I need to find the value of I of 0, right? So if I want to find the value of I of 0, it is initial current across flowing through the inductor. These two, the current source and the inductor is in parallel, right? Because I haven't connected that one. Now inductor means I need to short circuit that. So it will look like this. So the current flowing through the inductor is nothing but 4 amps, right? So I of 0 is I of 0 minus and 0 plus, it's 4 amps, and Vc of 0 minus and 0 plus is 15 volt. Okay, so u of minus t will look like this. Okay, so the amplitude of the u of t value is 1. Okay, if it is 30, u of minus t means it is 30. Instead of 1, you have to be 30. So t is greater than 0, the circuit will look like this, because switch get closed, right? The switch get closed, so it will be look like this. And when t is greater than 0, the 30, this is closed, so this will be percent. And here you can see 30 u of minus t is 0, right? If it is 0 means what will happen? It has to be short circuited, right? So You can see I have a source in I have a current source, right? So it is not source free. So and it is a step response. It is a DC value, right? And you can see on this RLC are in parallel. So if RLC are in parallel means alpha value is equal to 1 divided by 2 RC, and omega is equal to 1 divided by root LC. So you have to give 2 into, that is 10, 2 into 10 divided by into 8 milliamps, and LC is 20 into 8 milliamps. Okay. So why it is resistance value is 20 means you can see I haven't drawn the resistor in I haven't drawn the extra resistor because 30 u of minus t means that voltage is 0. If voltage is 0 means it has to be short circuited. It should not be open circuited. So you can see that resistance, the 20 ohm resistance will come in parallel with the capacitance and inductance and resistor. So if 20 ohm resistor is in parallel with 20 ohm resistor means what is the formula? If two resistance are in parallel, formula is R equivalent is equal to, if two resistance values R1 and R2, it has to be R1 R2 divided by R1 plus R. Okay, so you can see this is 20 ohm, that has to be, and this 30 u of minus t is short circuit. So now you can see the 20 and 20 ohm is in parallel, so the value is 10. Okay, if two resistance are in parallel and it is in the it's of same value, then the value is half of the value. Okay, so it should not be 20, it has to be 10. Okay, so now if I substitute the value, I will get the value of alpha and omega. So you have to compare the value of alpha and omega. So if alpha value is greater than omega, and if it is like equal to omega, and it may be less than omega. Okay, so for that from that one you have you can able to find the value, right? So alpha is equal to 6.25 and omega is equal to 2.5. So here alpha is greater than omega, so it is called as overdamped response. So if it is overdamped response means I can write V of t. Okay, it is parallel RC, no? So if it is parallel RC means it has to be I of t. Okay, so I of t is equal to, so note down, this is a formula. Okay, so I of t is equal to the current source value is 4 plus a into e power minus a1 into e power minus a1 into e power s1 of t plus a2 into s2 of t. Okay, this is a formula. So you need to find the value of s, right? So if I of t is equal to 0, I can 4 plus the I of 0 value is 4, so 4 is equal to 4 plus e power 0 is 1 and e power 0 also 1, so you will get a2. So a1 plus a2 is equal to 0. Okay, so from this I can write a1 is equal to minus 8. Okay, so next you have to differentiate this dA of t with respect to time. So you will get 0 s1 into a1 e power minus e power s1 t plus s2 a2 e power s2 t. Okay, so what is s? S is equal to minus alpha. This is a formula, plus or minus root of alpha square minus omega square. So we have already find the value of alpha and omega, so you substitute that value. Okay, so using a calculator you can find the value of alpha, right? Sorry, yes. So the s is equal to minus 6.25 plus or minus, so root of this value is just a minute. If it is a negative value, you have to write it as j, but it will not be a negative value, right? So root of 6.25 whole square minus root of 2.5 the whole square will be, so 5.728. Okay, so yes, you will get two answers, right? So minus 11.978 and minus 0.5 218. Okay, so you substitute it here. So this is your S1 and let me take this as S2. You can take either value, either any one of this value as S1 or S2. Okay. So you substitute the value of S1 and S2 in the respective place. So you can replace A1 as minus A2 here. But before that one, you need to find the value of di of t, right? So to find di of 0 of t, okay, that has to be minus 11.978. So e power value goes to 0, that is A1, minus 0.52188. Okay. So to find the value of di of 0 by dt, so you have to read out the circuit, that is when t is greater than equal to 0. So when t is greater than equal to 0, you can see the circuit will look like this, that is the 10 ohm resistor and have N and C, right? N and C, and you have a step response current source, right? This one. Okay. So since all the values are in parallel, so you can the voltage across this RLC is same, that is VC of 0. Okay. So I can write VC of 0, that is voltage across the capacitance, is equal to voltage across the inductance. Voltage across the inductance is L di of 0 divided by dt, right? So I can substitute now. L value is 20. So VC of 0 value is what is VC of 0 value? It is 15. So substitute that value. So from this I can find out the value of di of 0, that is 3 by 4. Okay, you substitute that value. So substitute the value in the above equation. 3 by 4 is equal to minus 11.978. Here itself you can substitute minus A2. But over A1 equal to minus A2. So you substitute it here. Okay, from this I can find the value of A2, right? Once if I find the value of A2, A1 is equal to minus A2. So you can find the value of I of, right? So now A2 is equal to so that is 0.0655 and A1 is equal to minus 0.0655. Okay, so you substitute these two values in the I of t equation, right? So I of t, that is first equation. I of t is equal to 4 plus A1 e power S1t plus A2 e power S1 S2. Yeah. So I of t is equal to 4 plus 0.0655 e power S1 value is this one minus S2 values this one. I have taken 0.0655 common. Okay, so this is I of t value. That should be unit is amps. So I need to find the value of IR of t. Again, they are asking what is current to the resistance. So I can write IR is equal to IR of t is equal to VR of t divided by R value. So, okay, so the VR of t is because the voltage across the parallel is common. So I can write instead of VR of t, I can also write this VL of t. Okay. So what is VL of t? VL of t is nothing but L dI by dt. Right? I can write L dI of 0 L dI by dI of t divided by dt. Okay. So it should not be 0. Okay, this is wrong. I have to write because they are not asking t is equal to 0 and all, right? So let me again explain this. IR of t is equal to VL of t divided by d, divided by 20, because the voltage across resistance, inductance, and capacitance are same. So VL of the t, I can write it as L dI of t divided by dt. Okay, divided by 20. So IL value I know, 20 also it's known value. dI of t divided by dt. So I of t value is in the above equation, right? So if I differentiate that value, you will get. So here the L value is also 20. See, it's like that. So if I differentiate dA of t by dt, that is the value of IR of t. Okay. So you know the differentiation value, right? 4 is a constant value, it goes to 0. And e power xt means it has to be x into e power xt, right? Differentiation. So this is equal to so plus I of t, right? So here it is I of t. This is what the question. So if I differentiate this one, I'll get L value is 20, so 20 get cancelled out, and this is 0.00655, and it is minus 0.5218 into e power minus 0.5218 t plus 11.978 into e power minus 11.978 t. Okay, so 20 get cancelled out. This the multiple will come inside, go inside. So you get the answer